Question 2. The function f is defined by this equation here. So f of x equals sine of x minus cosine of x for these x values. So we're only looking in the interval from 0 to 2 pi, including those two endpoints. What is the x-coordinate of the point of inflection where the graph changes from concave up to concave down? First thing you need to recognize is that a point of inflection would be the second derivative. So we need to find the second derivative of this function, specifically where it changes from concave up to concave down. So we're looking where the second derivative changes from positive to negative. So the first derivative of this function would be cosine of x plus sine of x. And the second derivative of this function is negative sine of x plus cosine of x. So I'm looking for a point of inflection. So on the second derivative, I'm trying to figure out where this equals 0. So I'm trying to figure out where that equals 0. In order to solve that equation, I can add this sine of x over to the other side. So I'll have cosine of x equals positive sine of x. So I'll start writing it over here. Cosine of x equals positive sine of x. And again, this is kind of just like a little trick. Like, you might not be able to figure this out without a calculator. And so what I'm about to do is kind of like a little trick to help you figure it out. So if we can get it to be just one trigonometric function, like just sine or just cosine, it would make our lives so much easier than keeping it as two that it's hard to add together when you don't really know. So here's how I'm going to do that. Here's how I'm going to make it just one trigonometric function. Is if you move one of them to one side, notice that we have this. I can divide both sides either by sine or cosine. So I'm actually going to divide both sides by cosine of x. And you'll notice that this side, cosine of x divided by cosine of x, is equal to 1. And this side, sine of x divided by cosine of x, is actually equal to tangent. So when you think to yourself, what value, and I'll erase some of this stuff so that I can rewrite this up here. What value of x will make tangent x equal 1? We can think of this like taking the arctangent on both sides. So essentially x equals tangent inverse of 1. So you need to figure out what values between 0 and 2 pi will make this equation true. So what values of x will make tangent inverse equal 1, or in other words, what values of x that when you plug them into the tangent function will equal 1. And the answers to that, there's two answers on the interval from 0 to 2 pi. The first one is pi over 4. Because you have root 2 over 2 divided by root 2 over 2, so that's 1. And the second one is in the third quadrant at 5 pi over 4. So those are the 2 points of possible points of inflection on the graph. From there, all we need to do is analyze which one of them is helping our function go from concave up to concave down. So we need to analyze exactly what our line looks like, or what our graph would look like. So at pi over 4, and at 5 pi over 4. That's essentially what we're doing. And I didn't mean to erase it, but if I remember back to what my second derivative is again, f prime, double prime of x, it was, I'm trying to remember now, negative sine of x plus cosine of x. And so in class, I keep telling you guys to, look at what the graph looks like and just go off of what the graph looks like. But you might not actually know what this graph looks like, so it might be necessary to plug in some values in order to figure out exactly what we're looking at. So if I can plug in a value less than pi over 4, so for example, plugging in a value like 0, if I plug in 0 to this, so f double prime of 0, that would be negative sine of 0, and sine of 0 is equal to 0. So negative sine of 0 would be 0 plus cosine of 0, and cosine of 0 is equal to 1. So that would be 0 plus 1. That's 1. So this is going to be positive values over here. And that automatically tells me that these values over here are also going to be positive because I'm thinking of a number bigger than 5 pi over 4, for example 2 pi. And if I plug 2 pi into that as well, I get the same answer. I get positive 1. So I know these values are going to be positive over here. And then in between, I'm thinking of a value between pi over 4 and 5 pi over 4. You can use any of them, but in my opinion, the easiest one to use is probably pi. So if I want to evaluate the second derivative for pi, I get negative sine of pi, and negative sine of pi is equal to 0. Plus cosine of pi, and cosine of pi is equal to negative 1. So that's a negative value. So all these values in between, pi over 4 and 5 pi over 4 are negative. So let's go back up to our question again. We found our 2 points of inflection, and they want to know which is the x value or x coordinate of the graph that would change from concave up to concave down. So we're looking for where down here we have change from a positive to a negative, and that occurs right here at pi over 4. You can see that the values are changing from positive to negative, which means that this is the value where our graph changes from concave up to concave down. And this one is where it goes the opposite direction, so concave down to concave up. So our answer is pi over 4, which is A. Final answer.